Now we are going to discuss 16th problem, which is from 1995 AIPMT. There is an electric field E in x direction. If the work done on moving a charge 0.2 coulomb through a distance of 2 meter along a line making an angle 60 degree with x-axis is 4 joule, then what is the value of E? So how to solve this? You know that force will be act in the direction of electric field only. So what is force? Force is Q into E. What is QE? E is not given, Q is given 0.2 coulomb. So 0.2 into E. What is displacement? Displacement is again given. We want to move this charge through a distance of 2 meter. Angle between F and S again given 60 degree. So we know from mechanics that work done is equals to F dot S. F dot S means Fs cos theta. So what should be work? Work should be F means 0.2 E. S means 2, cos 60 means 1 by 2. So what work we are getting? 0.2 E joule. But they gave us work done should be 4 joule. What is given? Work done should be 4 joule. It means 0.2 E, it should be equal to 4. So what should be the value of E? 4 upon 0.2, SI unit, Newton per Coulomb. Force experienced by unit charge means 40 upon 2 means 20 Newton per Coulomb. So we got the answer. So we will go with option number B. This was problem from 1995 AIPMT. Next. Now it is from 2005 AIPMT. As per the diagram, a point charge plus Q is placed at origin. What they are saying? Put point charge plus Q at origin. Work done in taking another point charge minus Q from the point A, coordinates of A are given on y-axis at a distance from origin, to another point B, coordinates are again given from on x-axis at a distance from O, along the straight path AB. Work done means, you know the formula. What should be work done? Charge into potential difference means charge into potential of B minus potential of A, but both points are at same distance from O. So potential of A and B due to that plus Q charge should be same. So whatever be the value of charge which is moving, but in this case it is 0. So work done should be 0. So we will go with option A. We will go with option A. Next, it is from 2006 AIPMT. An electric dipole moment P is lying along a uniform electric field E. Means initial angle was 0. The work done in rotating the dipole by 90 degree, we want theta to 90 degree. We have one formula with us. Work done is PE into cos theta 1 minus cos theta 2. So, PE cos theta 1 means cos 0 degree minus cos 90 degree. We know the values of cos 0 and cos 90. The values are 1 and 0. So, what we are getting? We are getting PE. So, we will go with option A. We will go with option A. Next, it is from 2007 AIPMT. Charges plus Q and minus Q are placed at points A and B respectively. At A, we would charge plus Q, and B, we put charge minus Q, which are at a distance 2L apart, and C is the midpoint, means they want to say distance from C to B is L, distance from A to C is L. Since they are making an arc, it means this distance again it should be L. The work done in moving a charge plus Q along the semicircle CRD. The work done in moving a charge plus Q means we want to move plus Q from C to, it will land at D. We know that in electric forces, work done is independent of path, depends upon initial position and final position, because this type of forces are conservative forces. So, what we have to do? We have one formula. Work done is equals to charge into potential difference. Charge we know, we want to move plus Q charge, but we have to calculate potential difference between C and D. Charge you are moving is plus Q, but we need potential difference between D point and C point. Due to this plus Q charge, what potential is at C? Due to minus charge, it should be same. So, first I am calculating potential at C, VC, due to these two charges. Due to plus Q charge, 1 upon 4 pi epsilon naught Q by L. Due to minus charge, minus 1 upon 4 pi epsilon naught Q by L. So, it becomes 0. What about VD? Now, we will calculate that VD. VD means potential due to charge A. First 1 upon 4 pi epsilon naught Q upon its distance from A is L, 3L. Due to negative charge, it should be negative, minus 1 upon 4 pi epsilon naught Q by distance of B from D is L. So, take 1 upon 4 pi epsilon naught Q by L common, Q by L common. Q by L common. What you will get? 1 by 3 minus 1 by 3 minus 1. So, we are getting minus 2 by 3 minus 2 by 3. So, q upon 4 pi epsilon naught L, and number is 2 by 3. So, it is Vd. So, what we are getting work done? Charge was plus q. Multiplied by potential difference, because Vc was 0. So, this formula will become q into Vd minus 0 means Vd, q into Vd. So, multiply by q, cancel this 2 with this 4, you will get 2. So, what we are getting? Minus q into q upon 6 pi epsilon naught L. Only one option is given negative, so we are going with C. So, C option was correct. Next, it is from 2008 AIPMT. The electric potential at a point in free space due to charge q is this volt. What is electric field at that point? What is the relation between EV? They are talking about only magnitude. So, relation is E is equals to minus dV by dr. So, using this, we are calculating E. Electric potential at a point in free space due to charge. Q coulomb is Q into 10 to the power 11 volt. The electric field should be, so we have two formulas for this. We don't have V. So, suppose distance is R. Suppose the distance of that point is R. So, first we will calculate V. What should be V? 1 upon 4 pi epsilon naught Q by R. 1 upon 4 pi epsilon naught Q by R. So, now we will calculate 1 by R. What is 1 by R? 1 by R is 4 pi epsilon naught V by Q. So, V is equals to E is equals to, now we can write this, we got this formula. Now, we can do one more thing. They gave us E. E is given. Q coulomb is, the electric potential is given, V is given. So, we can calculate 1 by R. Yes, we need, V is given, only R value is not given. So, we are going to calculate directly 1 by R. So, what we are getting for 1 by R? It is V into 4 pi epsilon naught divided by Q, divided by Q. So, now I am putting in E. E is V by R. dV by dr means dimensionally V by R. So, what is V? Is V. What is 1 by R? 1 by R means V into 4 pi epsilon naught by Q. We are getting this 1 by R means we are getting this. So, what is V square? The electric potential at a point in free space due to charge q coulomb is q into 10 to the power 11. V is q into 10 to the power 11. So q into 10 to the power 11 into q into 10 to the power 11 into 4 pi epsilon naught divided by q. Cancel one q. So what we are getting now? 4 pi epsilon naught q into 10 to the power 11 and 11, 22. We are doing in SI units, volt per meter. So 4 pi epsilon naught q into 10 to the power 22. Yes, in C we got this option. So we are going with C. Next, it is from 2009 AIPMT. 3 concentric spherical shells have radii A, B and C. Have surface charge density sigma minus sigma plus sigma. VA, VB and VC denote the potential of the 3 shells. Then for C is equals to A plus B, we have C is equals to A plus B, we have. What we have to do? They gave us 3 shells. See, one shell of radius A, smaller is given by A. After that, second shell, it is of radius B. Of radius B. Charge density minus sigma. Third shell, which is of radius C. C, charge density plus sigma, and first has charge density again plus sigma. We want to calculate electric potential of the 3 shells. First I am talking about A, V, A. Due to the charge, what is charge on A? Charge on A is, its area is 4 pi A square, means, and in per unit area charge is sigma. So charge is 4 pi A square into sigma. What is charge on B? Its area is 4 pi B square, area of sphere, and charge density is minus sigma. What charge is on C? Area is 4 pi C square, charge density again plus sigma. It is positive sigma. Now first we are going to calculate electric potential of sphere A. Due to its own charge, its charge is at a distance A from center. It will behave that whole charge is at center. So it is 1 upon 4 pi epsilon naught. Charge is 4 pi A square sigma upon at a distance A. Due to the charge on B, it should be negative. Its distance from its center is B. So what should be 4 pi? Charge on B is 4 pi B square into sigma. Its distance is B. Third charge plus 4 pi c square sigma upon c. You can cancel 4 pi and AA and c. So what we are getting? We are getting 4 pi cancel out, 1 AA is cancel out, sigma A upon epsilon naught minus sigma B upon epsilon naught plus sigma C upon epsilon naught. Now we will calculate electric potential of B. When we will talk about B, whole charge of A will go on the surface of B. It cannot reside inside. So distance of that charge from center is also B. So due to charge of A, its potential should be 1 upon 4 pi epsilon naught 4 pi A square sigma, but distance is B. What is distance? Distance is B. Due to that charge which is on B, 4 pi B square, 1 upon 4 pi epsilon naught, charge on B is 4 pi B square sigma, its distance is also B. Due to C, 1 upon 4 pi epsilon naught, 4 pi C square into sigma, it is at a distance C. We can cancel 4 pi. What we are getting? Sigma A square upon B epsilon naught minus 4 pi B cancel, sigma B by epsilon naught plus sigma C by epsilon naught. What is the charge due to C? Vc. Due to charge A, when we are talking about C, whole charge will go on the surface of outer sphere, means C. So its distance from center is C. Charge is 1 upon 4 pi epsilon naught. Charge on A was 4 pi A square sigma. Its distance from center is C minus 1 upon 4 pi epsilon naught. Due to charge on B, it will also go to surface of C. It is 4 pi B square into sigma by C plus due to C, 1 upon 4 pi epsilon naught 4 pi C square sigma divided by C. So what we are getting? We are getting sigma, cancel 4 pi, A square by epsilon naught C plus minus sigma B square by epsilon naught C plus sigma, C will cancel, C upon epsilon naught. So what we are observing now, what is A and what is C, what is B? In that condition, we can take sigma upon epsilon naught common. A plus C, A plus C is, A plus B is given C. C is equals to A plus B. In place of C, we can write A minus B plus C. They are saying C is equals to A plus B. A, B, B cancel out, it will become 2A sigma. If we put in place of C A plus B, B, B cancel out upon epsilon naught. What will happen here? B and B will cancel out. LCM, it is B. Okay, so if we are taking sigma upon epsilon naught common, we will get A square by B minus B plus C. If you write in place of C A plus B, B, B will cancel out. So we will get sigma upon epsilon naught. Here A square by B minus B and B. Sigma, in place of C we put A plus B, minus B, B cancel, plus A. What we are getting here, we will write here. Take sigma upon epsilon naught C common. Sigma naught upon epsilon naught C we can take common. So what we are getting? A square minus B square plus it will become C square. It will become C square. So if we use in place of C A plus B, sigma upon C epsilon naught. In place of A, I am eliminating B. In place of B, I am writing C minus A. So I am getting A square plus C square minus A plus C whole square. So what we are getting? B is C minus A. It is C minus A. We should write it. B square means C minus A. Now C square A square will cancel out. Minus 2AC will become plus 2AC. CC will cancel out. What we will get? Sigma 2 sigma A upon epsilon naught. So what we are observing, VC is same which was VA. So it means and VB is different. So we can go with option D. Concept was simple, calculation was lengthy. Concept was simple. If we put one sphere, another one hollow sphere, whole charge of this sphere will go on the surface of outer sphere.